Hi everyone! Welcome to the introduction video for Preperse Predispersed Pigments. Before we dive into Preperse, let me briefly introduce our company. For the past 20 years, we've been focused on applications in the plastics industry. Throughout our long business journey, we realized that traditional powder pigments have issues with dispersion, cleanliness, and environmental friendliness. So, 6 years ago, we started producing our Preperse Predispersed Pigments. As a development-oriented company with years of experience in producing and selling colorants for plastics, we've defined our mission as creating clean and easy-to-use colors. Here are some of the certifications our company has achieved so far. Besides the 3 ISO certifications, we are also currently undergoing Bluesign certification, which is an important standard for the textile industry. Additionally, we are recognized by the Chinese government as a high-tech enterprise. Next up is a quick look at some of our production and laboratory equipment. It's safe to say that our facilities are very well equipped for plastic testing. Here are some of the regulations and standards we comply with. We can meet the common certifications required for food contact materials. Now, let's get to today's main topic, the introduction of Preperse Predispersed Pigments. First, we all know the problems often encountered when using traditional powder pigments. The most prominent ones are dust pollution and their impact on health. Secondly, there's the issue of dispersibility. We know that different types of powder pigments have varying levels of dispersibility, and it's often difficult to achieve complete dispersion during use. This leads to many problems, such as color instability and various unexpected issues during production. Discontinuous production results in low efficiency. Furthermore, due to unstable dispersion in color, it's difficult for users to establish a unified, shareable database, which creates significant challenges for color matching. Fourth, powders are difficult to use with automatic feeding systems, making stable and highly efficient production hard to achieve. Most of the time, manual intervention is still needed, which also hinders improvements in production efficiency. We believe predispersed pigments are the best answer to these problems. Our Preperse Predispersed Pigments are in granular form with a pigment content ranging from 70% to 85%, and they are essentially dust-free. From the user's perspective, why should they choose predispersed pigments? We can summarize it with a few keywords. First, cost-effective. Second, easy to use. Third, clean. And fourth, high quality and stable. Firstly, its coloring power is 10% to 20% higher than traditional powder pigments, which offers good economic benefits. Users can add less to achieve the target color. Secondly, the granular form increases bulk density. This means we can pack more product per unit volume, thus saving on transportation and storage costs. Based on our calculations, this can save approximately 67%. Thirdly, it can boost production efficiency by about 50% to 70%. This is because its granular form and high dispersibility allow for faster feeding and production speeds. Fourth, with increased efficiency, energy consumption is also reduced, saving roughly 40% to 50%. Fifth is the advantage we mentioned, it's clean and eco-friendly. It's basically free of dust pollution, making it very user-friendly. Sixth, it saves on production preparation time. For example, there's no need for high-speed mixers, and cleanup is simpler and faster. This saves more labor and production prep time. Seventh, our Preperse Predispersed Pigments have good compatibility and can be mixed with various types of resins. Eighth, it can be mixed directly with granular resins. When producing high-concentration master batches, there's no need to crush the resin, saving time and effort. Ninth, it disperses thoroughly and offers stable color. It can be used to prepare more complex formulas, especially those with multiple components, 4 or 5 ingredients. Because each component's color is already dispersed and stable. 10th, whether using twin-screw or single-screw equipment, the product's color remains stable and won't change due to differences in machinery. We'll see data supporting this later. 11th is an insight we've gained from our own production. The process of making master batch using Preperse Predispersed Pigments is very stable, with few malfunctions. 12th, Compared to using powder pigments, the total cost of using predispersed pigments is actually lower. Additionally, users experience less anxiety, especially when producing high-performance, demanding products. This is what our Preperse predispersed pigments look like when mixed with granular resin. It's worth noting that the mixing process doesn't require a high-speed mixer, just ordinary mixing equipment with low speed. Uniform stirring is enough. We can confidently say this process is absolutely clean and dust-free. For many master batch producers, making high-concentration single-color master batch is quite challenging. Different pigment varieties have different characteristics, leading not only to dispersion issues but also to unexpected problems like unsteady feeding during production. This makes producing high-concentration single-color master batch tricky. Predispersed pigments simplify this goal significantly. They offer thorough dispersion, overcome feeding difficulties, and are compatible with automatic feeding equipment. We all know that formulating black with pigments is very difficult. This is because black requires multiple pigment components for color matching, and if any single component has unstable dispersion, the purity of the black suffers. A formula developed in a lab might result in a final product that's too reddish or too yellowish when produced at scale. Our Preperse pigment solves this problem. Whether in lab results or repeated production runs, this black remains stable. We also tested Preperse dispersibility using different equipment. We conducted an experiment using our Preperse Blue 15:3 product. Here are 3 sets of data. First set, the control group used master batch produced by a twin screw extruder in a single pass. The sample group used the same master batch but was processed through the extruder a second time under otherwise identical conditions. Color measurement comparison showed the data from both groups were consistent. Second set, the sample group was processed through the extruder 3 times. The color measurement data showed the sample still matched the control. Third set, the equipment for the sample group was switched to a single screw extruder. The results remained consistent. This indicates that the dispersibility of Preperse Blue 15:3 has already reached its peak. Multiple extrusions cannot improve its dispersion further. Our next experiment evaluated color strength improvement. We compared the color difference between master batch made with Preperse and master batch made directly with powder pigments, noting that we used the same batch of pigment for both. The experimental results show that Preperse increased color strength by approximately 13%. In this experiment, we used powder pigments from different sources to create 2 sets of predispersed pigments for comparison. PB15:1A was sourced from India, and PB15:1B from China. In their powder state, the color difference between them was significant. However, after being made into predispersed pigments, their color difference disappeared. This demonstrates the color uniformity achieved by our predispersion process after solving the dispersion issue. Next is a demonstration of the filter pressure value, FPV. Our FPV test standard uses a 1400 mesh filter screen. The pigment is made into a 30% to 40% single-color master batch, diluted to 8% or 10% during testing, and completes a test run with 60 grams of actual pigment. This is a very important reference index in the spinning industry. Users typically require an FPV less than or equal to 1 bar/gram, but our internal control standard is 0.8 bar/gram. This stricter threshold is to eliminate data deviations between upstream and downstream processes caused by equipment or other factors. Let's take some notoriously difficult to disperse products as examples. First is PB15:3. Our FPV is 0.023 bar/gram, this value is practically zero, and the curve is flat. This shows its dispersion is excellent and very stable. PB15:1. The powder specification of this product has even worse dispersibility than PB15:3. However, after our processing, the dispersibility of the Preperse specification fully meets the requirements of the textile industry. Our PA series Preperse pigments can also be used on PET/PBT resins. We also tested the pressure value of PBT master batch made from this specification. As shown, the pressure value of the PBT master batch also achieves excellent spinning grade levels. PR122 is another very difficult pigment to disperse. Although its color and overall performance are excellent, its dispersibility is very poor. Here we can see that after predispersion treatment, its FPV is excellent. Similarly, PV23 is as hard to disperse as PR122. A former Poly1 engineer told us their PV23 single-color master batch couldn't even achieve a pigment content of 30%. Using our Preperse pigments, the single-color master batch can reach up to 40% pigment content, with excellent dispersion. This is the FPV for our Preperse pigment PY139, tested by our spinning customer. The data is consistent with our in-house test results. Next, let's discuss another advantage of predispersed pigments: color matching. In this experiment, the control group was a green master batch prepared using single-color master batches PY139 and PB15:3. The sample group was a green master batch prepared directly using Preperse pigments. Color measurement showed that the colors of the two were very close. In fact, the full shade of the Preperse group was even greener. Therefore, we conclude that Preperse pigments can be used to replace single-color master batches for directly formulating custom colors to produce colored master batch. BASF has several series of predispersed pigment products, among which the microlens series is primarily used for polyolefin materials. We conducted comparative tests between Preperse and several products from the microlens series. We can see that our PY13 and PV23 performed better than their microlens counterparts. For PR48-3, while there was no significant improvement in color strength, our Preperse type is redder and has better saturation. Let's move on to the next part. Here, we studied the physical properties of our Preperse products, focusing specifically on how the additives within them impact end applications. This slide shows the results of our PP spinning trials using Preperse Blue 15:3. We adjusted the pigment addition ratio to evaluate the effect of its additives on the strength and toughness of the textile. In theory, the presence of more incompatible substances would lead to a worse elongation at break in the textile. However, our experimental results found that as the addition level of our Preperse product increased, the elongation at break actually improved. This indicates that the additives within it have good compatibility with PP fiber. In the case of PA fiber, no conventional wax is compatible with PA. Furthermore, excessive wax can lead to serious migration issues, as shown in this diagram. This creates a significant dilemma for PA fiber. On one hand, without a suitable wax added in sufficient quantity, it's impossible to solve the pigment dispersion problem. On the other hand, using an unsuitable wax or adding too much can lead to a decline in physical properties and spinability. Our predispersed pigment addresses both sides of this problem, perfectly resolving these problems. Additionally, we are currently the only supplier on the market that can provide a PA/PET series of predispersed pigments. Printed films are another common application scenario. Low molecular weight additives tend to migrate to the surface of the product, causing printing ink to peel off. We conducted a series of tests which proved that the additives in Preperse do not affect the printing results. Okay, let's wrap up by sharing some insights we've gathered from testing organic pigments in our lab. Have you ever run into this situation? A pigment fails in the lab tests but ends up meeting the standard once it's used in actual production? It's frustrating not knowing why. Well, often it's because production equipment delivers stronger shear force than lab machinery. That extra shear during processing usually leads to better pigment dispersion. This highlights a real challenge in the lab. Due to equipment limitations, test results for some hard-to-disperse pigments can be misleading, what we call a deception zone. Take a look at this curve graph. The x-axis represents shear force, and the y-axis represents FPV. The red line represents a pigment with higher pressure resistance. In other words, it has poorer dispersibility. The blue line, on the other hand, represents a pigment with better dispersibility. Now, if the lab equipment can't provide sufficient shear force, users might think the blue line pigment actually disperses worse. But in reality, the opposite is true. Once it's in production, that pigment's FPV performance far surpasses the others. This experiment shows that promoting Preperse requires close cooperation from customers. We often see clients testing Preperse with outdated methods and getting poor results. The granular form of Preperse isn't meant to be tested with 2-roll mills or small injectors. It needs to be fully melted and blended with resin to achieve complete dispersion. Finally, let's quickly go over our Preperse product lines. We currently offer PE, PP, PA/PET, and PVC series. The PE series is recommended for master batch production using LDPE, LLDPE, or HDPE, suitable for injection molding, extrusion, films, and similar applications. This series also works well for PP master batch in similar scenarios. The PP series is designed especially for PP spinning customers. They often prefer PP wax as a carrier to avoid affecting end product physical strength, so that's what this line offers. The PA/PET series is mainly used for master batches in PA fiber and polyester fiber, as well as other PA, PET, or PBT applications where high dispersion and eco-friendliness are critical. PVC customers rarely produce or use master batches, most prefer direct coloring with pigments or prep forms. Our PVC series comes in 2 forms, one is the common granular type, and the other is a crushed powder. There's no difference in performance, only in appearance. This gives customers options. The powder melts faster and can be used in smaller proportions, but it may generate some dust. The granular form is the opposite. That's it for the basics of Preperse. We'll have more videos showing how to use Preperse in real production and important tips to keep in mind.